Okay, so uh, this is having two sheets, orders and people. So I have selected orders sheet from there. Have a look on the columns. So we have fields related to order, ship dates, customer details, customer ID name. Then we have country information, city, state, region. Then we have category, subcategory, and the measures like sales, quantity, discount, profit, shipping cost, and order priority. So today we are going to discuss heat maps. So heat maps look like this. This kind of map is called as heat map. Only you're facing the issue. Rest of the students are able to see or not? Just a minute. I hope now you can see the screen. Just a minute. Now, please write on LPU Live. Please write your messages on LPU Live because I have to go to browser to check your messages. Okay, right. Now it's fine. Okay. So let's start. This is the global superstore dataset, right? I have taken orders sheet from there, and let's go to sheet one. Here you can see I've already created heat map. So the meaning of heat map is we have one kind of dimension and other kind of dimension on x-axis and y-axis. As you can see here in the rows, we have got the subcategory. In the columns, we have got the months extracted from the page. Now, why this kind of map is called as heat map? Uh, as you can see here, the circles on the map represent the sales. You can see the sales over there, right? In color, size, and detail. Now you can see some of the colors are darker and some of the colors are lighter, and some of the colors are larger in size. However, others are smaller in size. So this kind of chart is giving us a lot of detail in terms of the sales for a particular subcategory in a month, right? If I consider this example here for chairs in the month of December, as we can see, the size of the circle represents the sales, right? The sales, you can check out the sales from the tooltip here as well. And the color of the circle represents the size, represents the revenue, means the number of items sold. So actually these marks are telling us the density of the sales, right? Means more chairs were sold in the month of that's fine, the sales was higher, that's fine. For the lighter circles, if I check this circle, this is also similar to this in size, but as you can see there's a bit difference in the color. This one is bit darker, this one is bit more darker than this one is lighter. So this means that if the sales is 145 and this 133, that determines the size, but the color determines that how many sales were made, which determines the revenue, right? So here we can see this one is most darker, right? Similarly, if this color and this color look same, so this means this represents the number of items, the number of sales that were made on that marks, and the size represents the sale, right? So basically on a heat map, the color represents the density of that product, of that subcategory sold in a particular month, right? So this is very easy to create. How we can create it? Simply going to drag order date in the columns and going to extract month. Next, I am going to place subcategory, or you can place any other dimension as well, depends on the scenario. Going to adjust the size of the chart like this. Next, I'm going to put sales in color. So this is also the kind of heat map. You can also say that the chart that we have created is kind of heat map, and here we can see the sales are more in this. So here the sales are very dense, right? What else I'm going to do is I'm going to put the sales in size, right? And I'm going to change the chart to circle. Right, so this is the final chart that we have created. What else we can do is we can adjust the size of the marks like this. Now, whenever you're performing the analysis, that's fine, you can create the analysis, but you also need to know how to explain your analysis. Right now, if I just simply show you the map, you won't understand anything, but when I explain you, the larger circles represent more sales, and the more colored a particular circle is means the more dense the sale is for that particular subcategory in that particular month in this date dimension. Okay, so this is very much simple but a useful topic, creating a heat map. And I hope you understand the density. If I say that the color is more darker as compared to the other marks which are lighter, so this means that those the sales are more dense. Right here you can see, so both are same, but the size of the circle matters. So we are representing two things on this map. Please write in the chat box if you have got it. If you have got this topic, I have one more topic to teach you, which is creating Hexbins. That is more interesting than this one. Okay. Okay, shall we proceed further with the next topic? Okay, right. So next topic is this one. So what here we have is, okay. So firstly, what this data set is about. So here you can see we are using this data from downtown New York City, right? And basically what we want to do is we want to see the taxi activity by the time of day and location, right? Means we want to we will draw this city on the map, and we will determine the taxi activity, means what are those areas, what are those roads or highways in that particular city where taxi activity is more as compared to the areas where taxi activity is less, right? Don't worry, I will show you the screen just a minute. Okay, so what we will be drawing is we're drawing a map. We are drawing a hexbin map that will show us the density of taxi cab pickups and filter by the time of day, right? Okay, first I'll make you understand why there is need of creating a hexbin map. Just a second. Okay, so here I've got Olympic players data, and I'm going to drag in the sheet. Here you can see I have some records of Olympic players. I hope you can see the screen now, right? So what we are interested in knowing in this is height and weight of the players here. So let's go to sheet number 1, and I'm going to create an analysis. So this sheet will not be the sheet that we will be solving today. So this is just an introduction so that you get to know why do we need to create hex pins, right? And I'll tell you how to create hex pins on a map. So I'm going to select height and weight. I'm going to change the measure to average. Yes. Next, all the records are aggregated here. Oh, sorry, average is calculated. So I'm going to change this like this. I want it like this. Okay. So what we have got is, here we have got a scatter plot in which the points are plotted for each Olympic player in that data set, and we are knowing the average. Means from here the average Olympic players uh, weight is from here, like 45 to maybe this 120, and we have some marks after that also, right? And here we can check the height ranging from 140 to 220, right? If I change this to circle, and if I drag in the gender to the color, right? So here what we can see is, here we have some orange marks and some blue marks, right? But you can see that the marks are not visible. Like some of the orange marks are not visible. So I mean to say is, whenever we are creating scatter plots, what happens is we get we can get some plots over other plots. Like beneath we have the orange ones, over it we have the blue ones. But here from this chart right now, what I can see is majority of the players in Olympics are male, right? I cannot see any orange marks. If I uh, reduce some opacity, then also I cannot see any orange marks in between, right? So I can show you whether we have the orange marks or not from this sort option here. And here I can change to the descending. And here we can see, yes, we do have some orange marks as well, right? But what happens is, when we are using creating a scatter plot like this, we are not getting to know, okay, gender is one thing. Another thing is, I'm not getting to know how many participants are there which are having the average height 182 and average weight 88. For me, uh, I'm just taking note that there is one record over here, there is one record over there, but there are multiple records. So what we want to do on the map is, we want to sum up the records. Like if there are 10 records plotted over, if there are 20 records plotted over, I want to know, like, what is the density of the players having average height between average height 180, suppose, right? I want to know what is the density, and whether the players have more density, have whether more players have 180 centimeter height, or lesser players have 140. I cannot get to know about that information from here. Means I want to know the density of the marks. Okay, how many players are having 192 centimeter height and 90 kilograms of weight as compared to other marks, right? We want to make comparison of the marks. Okay, marks are plotted, that's fine, right? So this is the introduction. Why do we need to create the hex pins? So let's move to the analysis that I was telling you before. Just a minute. Can you see this text file or not? text file. Okay. Okay, so this is a introduction to the need of creating hexbins, right? Firstly, why do we need create hexbins is we want to map the distribution of data, which means showing the density of data across two measures, right? So what hexbins do is they create buckets of the view, which will help understand the distribution of data, right? So Tableau has two built-in calculations, hexbin X and hexbin Y, in which we need to mention the X and Y coordinates if we're using the map. So X will be the latitude and Y will be the longitude, right? So here also X and Y will remain same. So whenever we are creating the hexbins, it will be created for two directions, one for Y, X, right? In the rows we need to put Xbin X, and in the columns we need to put Xbin Y. Okay, so let me first tell you why hex pins and why not circles. So here I've drawn for you. Here you can see what happens is when we create circle marks. Okay, so this is hexagon. I'm going to take circle. So when we create circles, here you can see that the circles cannot tightly pack, right? So there will always be some space in the circles, but when we are using hexagons can be tightly packed, right? Because of these edges, straight edges of the hexagons. Moreover, what is why we are using hexagons over the circles is, here you can see the hexagon takes lesser area as compared to the circles. So we will be using hexagons so that they are tightly packed for the data that we have. And then we will color these hexagons like this in the shades of blue. So which will tell us if the hexagon is the most dark. So this means that we have more number of records which lie in that category, and then it is lighter. So this will tell us this point is less dense as compared to this one, and then the less dense than this one, and then the least dense, right? So if you consider this hexagon for the example that I've shown you from here, we can see that the more players lie in this particular category of height and weight, and then lesser and then least for these two, right? So I hope the idea of you creating the hex pins is clear to you. So let's solve the question that we were aiming to solve. So as I've explained you, this is the data from downtown New York City. And we want to see the taxi activity by the time of day and location, right? So here, have a look on the data first. It's a very large data set. You can see, so we have the pickup time, right? Then we have the pickup date. Then we have the important information that you need to know. is the pickup latitude and longitude. So these two will help us draw the map. Okay, so we will be using this as the filter, pickup time from here, evening, morning, for which time of the day we want to check the taxi density. So, okay, so what happens is when we are creating the map over there for pickup longitude and latitude, we are seeing something like this. Means there is there are records for this particular area on the map, but from this map we are not getting to know where is that point where the taxi density is more as compared to the other points. We're not getting to, we just know that we have some records over this area, but how much dense one particular mark is on the map, we're not able to judge it from this map. So the final map that we have created using the hexbin is this one. So here you can see we have created the hexbin map. As you can see, we've got this hexbin shape over there, which is tightly packed, right? So on the right side, you can check out, I've used the filter pickup time range. We can select a particular filter. Like if I'm selecting morning commute, for the morning commute, we can check out the density of the taxis. Where is the more dense? So at this longitude, like latitude, uh, we have more dense information related to taxis as compared to the other one, right? So this is the highway, you can see, right? This one is the highway on the map. Okay, and then also we can check for the evening. For the late night, it's less dense as compared to the midday. Morning, early morning is also less, and late night is also less, right? So very useful uh, tip that you can use in a map, right? Okay, so this is the overview that we will be overview of the chart of the analysis that we will be learning today. So let's start with this. Okay, so what's the process of creating the hexpin is, first is we need to create a parameter. That parameter at will suggest the size of the bins, right? How many marks do we want to have on the map? Okay, so by that I mean this. So this is the parameter. If I am changing this to 550, 530, so this is reducing the number of marks that I'm having on the map. So you can dynamically change these marks like this. Okay, how many marks do you want to have on the map, right? And next is, after creating the parameter, we need to create two calculated field, which will be hexpin and hexbin y, right? After that, after doing that, whenever we are using map, we need to convert those calculated fields to the dimensions, right? And then we also need to assign geographical role. So this is very important. If you do not, if you miss out any of the steps, you won't be able to see the required analysis, because now the longitude and latitude will be plotted by hexpin x and hexpin y. So we need to assign geographical roles to these. That's okay, just listen. Just listen. Okay, just a minute. Okay, firstly, we need to create a parameter which will determine the scale factor to adjust the size of the bins, right? Nextly, once the parameter is set, we will be creating two calculated fields, hexpin x and hexpin y. We must convert hexpin and hexy to dimensions. Once they are converted to dimension, we need to assign the geographical roles for them also, because instead of using pickup longitude and pickup latitude, we will be using this hexpin x and hexpin y in the rows and columns. And once that is done, we need to update the shape Okay, we want to use the hexbin. In the shape, you won't be seeing any hexbin file. So we have to customize our shape by adding the image of hexbin in the Tableau repository. I'll also tell you about that. Then we need to use that parameter so that we adjust the size of the bins, and also we need to put the number of records in the color. I hope overview is clear to you. Let's start. Don't worry if you do not get all these steps. You will understand these steps once we create it, but this was just about the introduction, how we will be creating the hex bins. Okay, so here I've created a new sheet. Firstly, we need a parameter, and that parameter we have to use in the calculated field. So let's create a parameter. And this time, this is the scale factor, but I'm going to name it as hexpin sizing, hexpin sizing, right? So here I'm going to select integer, and here I'm going to select the range, minimum, maximum, step size, and minimum will be 500, maximum will be, okay, minimum let's make it 50 or 100, and maximum I'm going to make it as 1000. And step size will be 10 in this case. So this parameter is created. Next, I'm going to create two calculated fields. The first will be hexpin x. Here I'm going to use hexpin x function. And here we need to use the pickup latitude. Now, the reason for that is, why do we need to write pickup latitude here is, here you can see, like, let's go to the map. Here in the columns, we have got the longitude. Now, longitude means these long lines in the map, in the globe, if you remember. And latitude means these horizontal lines. Okay, longitude is vertical, latitude is horizontal lines, right? So here this one is for, okay, first mark will be for the x point, and x point is horizontal. So here I need to mention latitude and then comma longitude, right? So this is the x mark and this is the y mark, and we need to multiply that by the scale factor, which I have created right now is hexpin sizing, right? So that those marks changes as per the selected hexpin sizing. Okay, one more thing is you need to make sure that you are putting latitude in the x and longitude in the y. If you put opposite, then we will get your chart the other way. And then multiply both, and then we need to divide as well. So this will be the formula. Apply this, okay. And next we need to create the same for y. So we need to create the same formula. Why don't we duplicate it? So I've duplicated it and then rename this. Okay, let's edit it. So here I'll rename this to y. And only a single change here, that is y. Here you can see I've already created like two hexpin x and hexpin y calculated fields before for the previous analysis. So here you have to use the function f function hexpin y. So this is the correct one. Apply this. and OK. So now we have got the calculated fields and the parameter embedded in those calculated fields. And hexbin X and hexbin Y is now a measure. We need to convert these two as dimensions. To can put it here. And next we need to assign a geographical role because hexbin X will be in the rows and that will be the latitude. So where we are going to assign a geographical role which is latitude. And here we are going to assign a geographical role which is longitude. That's fine. Now we have got the geographical roles assigned here. So next we can use these here. Okay. Make sure you put Y in the columns and X in the rows. So we have got something like this with initial marks as 100. If you remember, I had used 100 marks in the parameter. So from here, I'm going to show the parameter that I've just created, hexbin sizing. And from here, we can increase the marks. Okay, like this. You can see if I increase that marks on the parameter, the chart become more tightly packed. Let's make it to 530. Okay, what you can do is we can zoom this a bit. Okay, the jitna zoom hum karenge, the more we zoom it, we will see the more sparse marks. So I'm going to increase the size of the bins more, like this, to 600. And next I'm going to show you this part of the map like this. Okay, right now here you can see the mark which is used here is circle. So we need to convert this chart to shape. And from this shape, we need to choose the shape. But by default, you won't see any hexagon. So here you can see I've created a customized shape palette in which I've just put one symbol here. So what you can do is you can download. Okay, how to do this is you can download any hexagon image from the Google, right? You simply write hexagon, whatever mark you want, you can write that. You can download .png image of that, right? After downloading the image, just a minute, let me show you the screen. I hope you can see this documents screen now. Here I need to go to my Tableau repository. Over there you can see these shapes, and here you can see this hex folder that I've created by myself. And then when you click OK, here you can see this was the image that I had downloaded. So you can simply paste it over there after downloading, and you can even paste more hexagon, like just the outline or with a different color or so. And here you can see if I show you these, so these are also the images that have been put in the Tableau repository. Okay, so it's very easy to put a hexagon image over here. Just a minute, I'll show you the Tableau book. Okay. So I hope now you can see it. So from this shapes, we are going to choose the shape that I have just saved it in the Tableau repository. I've shown you I've saved previously. So from here we can select that mark, and thus you can see the mark is applied. Okay, so what next is how we can know that whether some of the marks are dense, other are less dense, is that from the number of records. So number of records when we put in the color, so wherever we have more marks on this area, that will be colored more darker blue. So going to select number of marks and put in the color. And from here, I'm going to increase the size of the marks like this. What else we can do is, here you can see here we have the shading done. So what we can change here is, we can also vary the color on the map according to some steps. This step means first step will have the same color, second step will have the same color like this, and so on. And here I can choose the range by going clicking on the advanced. I've already discussed in the class. Here we can mention our customized range. As you can see, in our case it's 100, right? Or maybe we can select 50, right? When the number of records are 50, for that it should color the first step. Then it depends on the last one. If I select maybe 700 here, so according to the steps, from starting from 50 to 700, the records, number of records, if they are 50, colored lighter, and then in the next step they will be colored bit more darker, and so on. So apply this, and okay. Okay, let's change this to more. Okay, fine. So this is the range that we have decided. Okay, one more thing. We wanted to select the time of the day, right? Means at what time of the day there is more density, right, of the taxis on the highway as compared to the other time. For that, here we can see we have this pickup time ranges dimension. I'm going to put in the filters, and let's select early morning. And okay. Next, I'm going to show this filter, and from here we are going to change to the single value list. Because I'm going to adjust the size. Just a minute. Okay. It's very coming out very dark, light. Just a minute. What was that I had fixed before from 1? Okay, so we are putting way more. Yes. Let's make it from 1 to 500. That will be correct. Yes, so this is the final chart. As you can see here, we have got the marks, which is more dense. Okay, next add another layer on the map. So from the map, we can select map layers. And here we can select streets, highway, and routes. So then the highways and streets will be drawn. So this is the highway. Okay. So I hope you can gain more insights in your analysis by using Hexbins in your maps. If anyone's having doubt, can ask. Anyone's having doubt, can ask. Good. So I'll provide you this data set and a question that you'll be solving, right, in your LP Live group so that you can solve this.